In this video submission, I have presented my project for the course IFT 530 Advanced Database Management System. I have implemented COVID vaccine management system for the project submission, and I will be presenting my screen and going through the introduction of my project. It is presented by me under the guidance of Professor Dr. Robert Tucker. Summary. In this project, I've mainly aimed to develop a COVID-19 vaccine management system. So the system is used to automatically allot a vaccine administered to an individual based on their age, and also to check if only 2 doses of vaccine have been administered, and that dose 2 is administered only after dose 1. The project also aims to answer a few important questions about the vaccinations administered to individuals, along with a few statistics that is related to the COVID virus outbreak. So the main questions answered by this project are discussed in the upcoming sections. And to give an overview, I have implemented 2 procedures, 2 triggers, and 1 user-defined function. And there are 5 main queries to answer the questions that I've tried to find answers to. And I've also created ORM and DRD diagrams for the system architecture to explain the system architecture better. I've also implemented the NoSQL perspective of this project with 2 buckets and 3 main queries. These are based on the tables of the RDBMS COVID-19 vaccination management system. So COVID-19 is an epidemic outbreak with nearly 550,000 cases and 25,000 deaths worldwide. The virus belongs to coronavirus family, which infects both animals and humans. So the symptoms of COVID-19 can be very similar to the flu: dry cough, sore throat, a runny nose, fatigue, fever, aches, nasal congestions, and pains. So according to WHO, vaccination is a simple, safe, and effective way of protecting yourself against the harmful disease before you can encounter them. So it uses your body's natural defense to build resistance to specific infections and make your immune system stronger. So there are a few vaccinations available to prevent or reduce the COVID-19 from infecting an individual. And in the US, there are 3 main vaccinations that are approved, namely Pfizer, BioNTech, Moderna, Johnson & Johnson. So there's a need to keep track of all the individuals who are getting vaccinated with the 3 main COVID-19 vaccinations, which I just mentioned. And in this project, I've tried to achieve that goal mainly. And the software also enables vaccine management and also has the potential to share data among healthcare providers, recipients, hospitals, agencies, local, state, and even the federal governments using secure and centralized databases. So along with managing the administration of vaccines, the project aims to answer a few questions about the outbreak and statistics of the disease which is spreading. Coming to the context. So the vaccination system mainly administers the recommended vaccines to individuals based on their age and also keep a track of the medical information of an individual, the address where they reside, vaccination status of an individual, the information about the 3 vaccinations available, that is Johnson & Johnson, Pfizer, BioNTech, and Moderna. So where are these vaccinations being administered? That is mainly the address of the facilities, infection history of an individual, and which of the 2 variants, namely for this project, I've considered the Delta and the Omicron variants. So the solution is designed to provide real-time data and access to vaccine administration and help the concerned healthcare providers to make their decisions. The software can also be used to find the statistics of the individuals who are infected location wise and people who have been vaccinated even after getting infected. So a few of the recognized entities in my CVMS are as are discussed in the upcoming slides. So coming to the queries. So the queries in this project include DML, DDL, TCL, DQL queries. So DDL stands for data definition language, and it has been used to define the tables and schema of the project. For example, I've created the person table using these the data definition language queries. So DML stands for that data manipulation language, and it is mainly used to insert and update data into the tables. For example, here I've inserted data into the medical information table as follows. Data query language. So it is used for performing queries on the data. So select is one of the data query languages, example of it. And TCL, it is a transaction control language, and it has been used in one of my triggers, and I will show it in the trigger part of the project. So coming to the main queries in this project are the stored procedures, triggers, user-defined functions, and the questions which have been answered in this project. So the stored procedures are allot we, that is allot vaccination or count vaccination uh, uh, in a particular postal code. And the two triggers are a trigger to update the age in the age calculation table and to check if dose 1 has been administered before administering dose 2, as I already discussed. And the UDF stat to find how many people have been infected, and then to be more specific, how many females have been infected or how many males have been infected or not infected. We can use this user-defined function. So some of the questions that have been answered in this project include the following. So how many people of a particular age have been, or above a particular age have been vaccinated with all the 2 doses of vaccine? And how many people who are infected or not infected have been given at least one and at least all the 2 doses of vaccine? How many people who have been administered a vaccine and in which type of vaccine has been administered? Like I already mentioned, the 3 type of vaccines, which of those 3 has been administered and in which facility? The total statistics of people who have been infected and not infected, and it is grouped by gender. People who have been infected with a particular variant in a particular city of a given state. This is the ORM diagram for my project. It includes 10 main entities. The first entity is person. A person entity has first name, last name, email, and phone number. Age calculation. This is automatically inserted table, like the data into this table is automatically inserted. It includes the group of to which an age, particular age belongs, that is which a person belongs to which age group, and also their age, infection history, whether the person has been infected in the past, and the date of infection, and the type of infection. The 2 main infections include Delta and Omicron that I've considered for this project. So Delta has runny nose and Omicron has sore throat, according to my assumptions for this project. And this is one of the constraints where for each date of infection and person, at most one infection history has that date of infection and has that person, like one person can have one infection at one particular time only. And the person's medical information includes height, weight, gender, date of birth, and whether they have been infected in the past. And coming to the vaccination status of a person, how many doses of vaccine they have been given, on which date, and which vaccine they have been given, the name of the vaccine, and which facility, like that is the vaccination will be located at a particular facility. And the vaccination information table includes attributes like the vaccination information, that is to which age group the vaccine can be administered, the description of the vaccination, and on which date the vaccine was approved. And the person table, like a person will reside at a particular location. So the location is common table here, where a facility details, like where a facility is particularly located, and the person where he resides in a particular location. So the relational view of this particular ORM diagram is as shown. The 10 main entities and all the primary key and foreign key is also defined. This is the ERD diagram that has been generated in SSMS. So these are the 10 main tables, and the foreign key, primary key is all represented in this, and also the how each table is related with each other. Coming to section 4, where we need to describe the relational database tables. That is the 10 tables which have been defined in my ORM diagram. So the first table is person table, the schema for it, location table, resides at table, medical information table, age cal table. The values into this table are automatically updated using a trigger, which I'll be explaining in the video. The vaccination table, vaccination information table, located at table, infection history table, and the type of infection table, that is the Omicron or the Delta variant table is stored. So data manipulation language, that is insert and select statements used in my project. So inserting data into the person table. So this is the whole data set in person table, the location table and its data set, the resides at table and the data set. So medical ID 1 resides at location ID 4. Coming to the medical information table, it includes medical ID, height, weight, date of birth, gender, and infected. The date of birth is used to find the age of a person and therefore find out which vaccination needs to be administered to that particular individual. Age cal table, which is the age calculation table. So medical ID 14 is age 27 and belongs to group adult. So this age is calculated based on the data that is stored here. Vaccination table. The values into this table is mainly inserted using a stored procedure, and it includes the following attributes: medical ID, vaccine name, vaccine date, dose number, and facility name. Vaccine information table and the located at table. So there are 5 main facilities and their location IDs. Infection history table, whether a person has been infected and the date of infection and the type of infection. And the type of infection table, where the 2 subtypes have been defined, the Delta and the Omicron. Column constraints. So constraints on column dose number, to make sure that dose number is either 1 or 2. That is, we can't have dose number 3. This is the constraint that has been tried to achieve in this constraint, a column constraint. And the second constraint is to check that only 2 variants, that is Delta or Omicron, are allowed to be inserted into the table. Foreign key constraints. So there are 2 and 3 foreign keys that are enforced in tables, infection history and vaccination tables respectively. So we can see that in infection history, there are 2 foreign keys, and in vaccination table, there are 3 foreign keys. So coming to section 5, I will where I have discussed about the stored procedures and triggers, user-defined functions, and the queries of my table. I will be explaining it using SSMS. Now I will go through the triggers and the stored procedures used in my project. I have made a few assumptions. The assumptions are about the age categories and the vaccines that are administered to these particular categories. So if age is less than 12, then the individual is a child, and if it's between 12 and 21, then they are teens, and if age is greater than 21, then they are adults. So for children, Pfizer BioNTech is administered. For teens, Johnson and Johnson is administered, and for adults, Moderna is administered. Coming to the first trigger, which I have implemented, is the age update trigger. This trigger is triggered on inserting a value into the medical information table. So the medical information table has date of birth as one of its attributes. Using this attribute, the age of the person is calculated. After calculating, it is classified as child, teen, or adult and inserted into the age calculation table. The values are automatically inserted, and the values which are inserted are medical ID, calculated age, and the classification. Let us have a look at the persons table. So we see that 28, 29, 30 medical IDs have been entered. And let us see if their information exists in the medical information table. We see that 28, 29, 30 have not yet been inserted into the medical table. And let us see if their information exists in the age calculation table. So again, we see their entries are not in the age or calculation table. Now we'll insert data into the medical information table, which includes the date of birth. So the person's age should be about 12 years now. So let's see the medical information table if it has been successfully inserted. We see that the 28th medical ID has been inserted and the date of birth. So let us have a look at the age calculation table again. And the age is 12 years. So the trigger has inserted the value into the age calculation table, and the trigger definition is as follows. Coming to the second trigger, which is dose 1 check. So we have to make sure that dose 2 can be administered only after dose 1 is administered. So if dose 2 is tried to administer without administering dose 1, then an error is raised which reads dose 2 cannot be administered without administering dose 1. So in the medical information table, we see that 25th medical ID has not yet been inserted. Now, there not even one dose has been administered to this 25th medical ID. We'll try to administer dose 2 without administering dose 1. We see that we get an error which says dose 2 cannot be administered without administering dose 1. And the value has not been inserted into the vaccination information table. So now let's administer first dose and see if it's been inserted. So the first dose has been administered successfully. This is the definition of this particular trigger. Let us go through the stored procedures used in my project. The first stored procedure is allot vaccination, that is allot V. The procedure is used to allot a vaccine based on age. The user inputs the fields like medical ID, vaccine date, dose number, and facility name. The vaccine name is automatically selected while invoking this query. The field vaccine name, which is the vaccine to be administered, is based on two tables. The two tables are HCal and the vaccine information table. In both these tables, we have the group attribute, that is the age category of the individual. The vaccine name is automatically picked from the vaccine information based on the group attribute which is present in both the tables. Let us see it's working. So let us first see what values are present in the vaccination table. So we see that for 27th entry, there's no data yet. They have not yet been administered any vaccination. Now let us insert the value for the vaccine information for medical ID 27. Let us have a look at the age group of this 27th medical ID. So medical ID 27 is 7 years old, so they're child. According to this, Pfizer BioNTech needs to be injected. So now let us run the stored procedure. It has returned a value of 0, which means it has been executed successfully. So 27 medical ID has been administered with Pfizer for the first dose. The second stored procedure used is the count vaccine in a particular postal code. So this stored procedure is mainly used to find how many people have taken what type of vaccine and in which facility given a particular postal code. So 3 people have been vaccinated with Moderna in CVS facility in the location ID 5. And the postal code which we passed as a parameter was 85281. For this particular entry, let's verify the data. So location postal code 85281 has 3 people who have been vaccinated. So location ID 5 is 85281 and location ID 5 is in location ID 5 CVS is located. The facility name is CVS and 3 people have been administered Moderna in location ID 5. There are no other entries for CVS, hence we can verify that this stored procedure is working successfully. Coming to the user-defined function of my project, when we would like to find out how frequently the males and females have been infected or not infected, this UDF stat can be used. The values passed to the UDF are the gender and the bit 1 or 0 for infected or not infected respectively. So we would like to know how many females have not been infected. The statistics says that 6 females have not been infected with any type of infections. So there are 6 entries where the gender is female and infection is 0 from the medical information table. So this is the procedure definition of this particular UDF. So now I'll go through the queries that have been executed on my project. That is the questions which my project tries to answer. For the first query, we would like to know how many people above a particular age have been vaccinated with all the 2 doses of vaccine. So 3 people, medical IDs 14, 15, and 22, who are above the age of 20 have been vaccinated successfully with 2 doses of vaccine. Coming to the second query, the total statistics of people who have been infected or not, and this should be based on the grouping of gender. We see that 6 females and 7 males have not been infected. 9 females and 6 males have been infected. This is the statistics which the researchers can use to do research on. And coming to the third query, people who have been infected with a particular variant in a particular city in a given state. So I would like to know in California, how many people have been infected with the Delta variant?
we see that medical ID 8 and 10 have been infected uh, with Delta variant, and their names, their location IDs, and which city. People who have been infected or not infected and have at least been given one dose of vaccine. This is the fourth query which I've tried to execute. So uh, at least one dose has been administered to these medical IDs. Let's see how many people have been uh, vaccinated with both the doses. So these three people have been vaccinated with both the doses and they're not infected. Let's see how many people who have infected and been administered both the doses. So Joe has been infected and both the doses have been injected to him. Coming to the fifth query, how many people have been administered and what type of vaccine and in which facility? So the facility name, the vaccination name, and the number of people who have been vaccinated in this particular facility is displayed.
Section 6, NoSQL. NoSQL databases are purpose built for specific data models and have flexible schemas for building modern application. NoSQL databases are widely recognized for their ease of development, functionality, and performance at scale. So the NoSQL is implemented using a Couchbase Enterprise Edition for the RDBMS counterpart of this project. This is how the dashboard looks like after configuring it. Coming to the buckets that I've used for my NoSQL implementation are the person bucket and the medical information bucket. I will go back to the ER diagram of my RDBMS project and show which two tables have been nested in these two buckets. In the person bucket, the location has been nested, and in the medical information table, vaccination has been nested. Indexes have been created on both these buckets. And the person bucket, this is a JSON format of the data that has been inserted. This is a table format. So medical ID 1, their first name and last name, email address, and the phone number, and the location in which they reside. This is the nesting. Coming to the second bucket, that is the medical information bucket. The medical ID, height, gender, date of birth, and their weight. Also the vaccination information, which includes the dose number, in which facility it was administered, the date of vaccination, and the vaccination that has been administered, the name of it. It also contains multiple entries when people have been injected with both the shots. There are three main queries that I have executed on these two buckets. So coming to the first query of the using the analytics service, the first query is used to find the age of the person from the date of birth stored in the person bucket and display it along with the height and weight ordered by the medical ID. So the age has been calculated using now string function and dateDiff string function. These functions are available in N1QL function list. So medical ID 1 is weighing about 70 kgs and their height is 156 centimeters and the age is about 24 years, calculated using the date of birth stored in the person table. The second query is to count how many males and females have taken their vaccination and in which facilities. So in CVS facility, 3 males and 3 females have taken their vaccination. Similarly, in Daisy Family Health, 2 males and 2 females have been administered vaccination. And in Mountain Clinic, only males have been administered and 5 males have been administered with vaccination. Coming to the third query, it is to find the name of people who have taken both their vaccination and in which facility. So Stella has taken 2 doses of her vaccine in CVS facility, their medical ID. And similarly, Boyle has taken both their doses in the Mountain Clinic, and their medical ID is 7. This is a simple implementation of the RDBMS project that I have implemented using NoSQL. In summary, the project made use of RDBMS to develop the COVID-19 vaccine management system. The system was identified with 10 main entities. The ORAM diagram was used to generate the relational schema diagram and also to generate the SQL code. The server management studio was used to implement the schema along with all the tables. Triggers, stored procedures, and user-defined functions, primary keys and foreign keys, other column constraints were used to maintain the integrity of the data in the database. The main objective was to administer the government recommended vaccine to the right age group, and this has been achieved using the stored procedure and triggers. Also, the condition that administering only 2 doses of vaccine and that the second shot is given only after the first shot has been also been met. Statistics of the novel coronavirus can be queried to know how the virus is spreading and how many people based on gender are getting the infection. The statistics of regional spread of the variants of Omicron and Delta can also be queried. The project also helps us to find out the popular vaccination facilities where people are getting vaccinated. A NoSQL perspective of this project was also being implemented. In conclusion, the project has the potential to be large upscaled, where the government can rely to administer the right vaccine to the right age group. The project can also be upgraded to find popular facilities, since statistics of which facility has the most number of people being vaccinated in it can also be queried in this project. This in turn can give rise to a management system of vaccinations delivered to a particular facility to increase the flow of vaccination to a particular facility to be more precise. This project also has a potential for researchers to extend it to find at what rate the virus is spreading and is vaccination administered to individuals are being of any use, if at all. The rate of vaccination and infection also gives the researchers a final level of control to extend the project and find at what rate and at which location the virus is spreading. And based on this, the government can take actions accordingly. Now I'll quickly run you through the section 5, 6, and the summary of the project in the report. So the additional constraints, the stored procedures, the stored procedure 1, allot V. The second stored procedure, the triggers, the second trigger used in my project, the UDF, and the 5 queries that I've queried on my database, the NoSQL implementation and its configuration, the buckets and nesting of tables, and showing the data that is being inserted in both the buckets. Queries using the analytics service, summary, conclusion, and the references for my project.